Well, excuse me, we have another question here. Question 3. The question says that if R equal to 1/5 and A equal to 2000, determine question 3.1.1 then determine okay, Tn, the general term of the series. All right. The fact that I'm gonna write the question here, 3.1. Okay, we have like R equal to 1/5, and then A is equal to 2000, and then 3.1.1, 3.1.1. We want, they say, determine Tn. Okay, the general term of the series. Okay, the fact that I can see R here is 1/5. 1/5 is in between -1 and 1. Okay, this tells me that this type of sequence or series is a converging. Okay, this geometric pattern converges. Okay, so we can use okay, now let's continue. Okay, it's a geometric series because we talk about R. So the geometric series is given by Tn equal to A R to the n minus 1. So now Tn will be equal to A, the first term, which is 2000. Okay, and then R is 1/5 to the power of n minus 1. So that's that's Tn, the term Tn. Now question 3.1.2. It says T7. Okay, if we know Tn, we can find T7. So this means T7 will be equal to 2000. Okay, 1/5 to the power of n 7 minus 1. So we can use a calculator for that. So this would be 2000, open brackets, 1/5, close brackets, and then to the power of 7 minus 1. So, and then when we hit equal, and then we have like 16/125. So therefore T7 is just 16/125. That was 3.1.2. Now we're going to do 3.1.3. The question says that which term of the series will have a value of 16/15,625. Okay. I'm gonna move my board over here. 3.1.3. So we're looking for a term Tn, okay, which will have a value of 16/1500,625. Now, how can we do that? We know that Tn is given by 2000, okay, 1/5 to the n minus 1. Now we're going to substitute Tn by 16/15,625. Actually, when they say which term, we're looking for n. Okay, so it's like we're looking for n here. 2000, 1/5, n minus 1. Now, in a situation like this, okay, I prefer to keep my unknown on the left. So I will reverse it. So 2000, 1/5 to the n minus 1 equal to 16/15,625. Now we can get rid of the 2000. If I divide both sides by 2000, I'll divide here by 2000, and then I'll divide dividing by 2000 means that I can divide here the denominator by 2000. So this will be, I will be left with 1 over 5 to the n minus 1 equal to, we can just do 15,625 times 2000, oops, 3 zeros, okay? This is equivalent to 3125, and then how many zeros? 4 zeros. Yes, 3125, 1, 2, 3, 4 under 16. Okay, can we simplify this? Okay, let's see. I think we can simplify 16 over 3125, 1, 2, 3, 4 equal, yes, we can simplify. That's 1953. Okay, it's gonna be 1953. What else? 125 under 1, and that's 1 over 5 to the n minus 1. Now, in a situation like this, we must look at this number. Try to write the number in the denominator in terms of its prime factor. How can you do that? I'll show you. In the calculator, write 1953, 125, okay? And then press the equal button, okay? And then press the shift button, and then look for the button fact. In my case, your calculator is somewhere here. Okay, when you hit fact, and then it tells you what the number is in terms of its prime factor. So it's 5 is a prime number, so 5 to the power of 9. Now this will be then 1 over 5. 1 over 5 can be written as 5 to the negative 1, or I can just skip it like that. 1 over 5 to the n minus 1 equal to 1 over 5 to the power of 9. Okay, now you know that I want you to notice that 1 is 1 regardless of the exponent. 1 to the power of 2, still 1. 1 to the power of 1000, still 1. So therefore, I can also put here 1 to the power of 9. Why am I doing so? Because there is a law of exponent that says if you have a to the n over b to the n, this is the same as a over b to the power of n. Okay, so we can write this like 1 over 5 to the power of n minus 1 equal to 1 over 5 to the power of 9. Okay, now that's the bases are the same, we can just cross the bases and then equate the exponents according to the law of exponent that says a to the m equal to a to the n implies that m equal n. So over here, we'll say n minus 1 will be equal to 9. So if I move the negative 1 over, I'll have 9 plus 1. So therefore, n is equal to 10. So in other words, it is the 10th term. So it's T10 that is equal to 16 over 15,625. Okay. Thank you.